Hi everyone, my name is Architect Francis Geshohe. I work with A4ARCHITECT.com and I'm here to present to you the A4ARCHITECT.com diamond house plan methodology of construction that effectively reduces 32% of construction cost. This is achieved through 3 easy steps. Steps number 1, use of creative construction technology. Step number 2, use of phased construction. And step number 3, use of labor-based procurement method. In the course of this movie, I'll explain to you this in finer detail so that you get the big picture on how all this is achieved. Welcome. To demonstrate how the A4ARCHITECT.com diamond house plan technology works, we are going to use the diamond house plan as an example. This is the diamond house plan as we are looking at it, and this is phase 1. Phase 1 comprises of the living room area till this level here. It has 1 bedroom. Then phase 2 comprises of the living room area till this level here, that is 2 bedroom. Then phase 3 is the final phase, comprises of all the way from the living room at this end till the master bedroom on the other end. And we can have a look at the diamond house plan. And the living room, it has a horseshoe design, whereby this is the main entrance. From this main entrance, it accesses the corridor that goes to the bedroom on this side, and the passage that goes to the living room. And you can see the horseshoe arrangement of furniture. Furniture is arranged all around the exterior walls of the living room. This is the corridor. You can see how the furniture is arranged all around it. This horseshoe design helps in making sure that most of the living room's floor space is utilized by laying out furniture as opposed to being used for circulation. For example, if assuming, let's say our door was here, that means this table wouldn't have been here. It will have had to pave way for the corridor. That is what the horseshoe design comes to solve. And from the living room, this is the toilet. There is a toilet here just near the entrance, and we can look at it from the floor plan. Now this is the entrance, this is the living room, this is the horseshoe shape that we have just looked at, and this is the toilet that is next to the entrance. That's where we are. This is the entrance, this is that toilet. Then this is the end of phase 1. There is the bathroom next to this toilet. This is what marks the end of phase 1. Here, this is the bathroom next to the toilet at the entrance. This is what marks the end of phase 1, and phase 1 is 45 square meters. And from there we move to phase 2. Phase 2 is 67 square meters, and comes till this region, comprises of 2 bedrooms. And when phase 2 is operational, this bedroom that was initially being used in phase 1 now turns into a kitchen. So phase 2 operates with these 2 bedrooms with a large kitchen, and the kitchen for phase 1, which was here, now becomes the dining room. Then the last phase is phase 3, which has the master bedroom here, and part of phase 2, bedroom number 2, because phase 2 is constructed till here. The bedroom number 2 has been designed to have this constriction here that separates the bedroom into 2 spaces. The space 1 can fit a bed, space 2 can fit a bed. This constriction will help in that when the phase 2 is complete, there can be a door here, and when phase 3 is put, the door is removed, and the 2 bedrooms merge smoothly. Also, in case bedroom 3 occupants would like to have a large bathroom with a jacuzzi, this space of bedroom 2 is the most appropriate for that use. We can look at it in 3 dimension. This is where we are talking about. This is bedroom 02. This is the phase 1. This is the first phase. This is the first part of the bedroom, and look at it here. It constricts to the second part of the bedroom, and this constriction somewhere here, when phase 2 is complete, can be closed with a door in readiness for phase 3. Once phase 3 is complete, the door is removed, then the whole space merge, and the same space is what can be used as an extension of a large bathroom or jacuzzi for the master bedroom. And we can look at, this is the master bedroom. Here it has a window that faces the front and another window that faces the back side. Here we are. This is the master bedroom. We can look at it in floor plan. Here we have this window faces the front, and these are the window facing the back side. And in case the master bedroom occupants would like to have a large bathroom or a jacuzzi in future, this is the right place to locate it. Now we can look at the exact technology that is enabling us save the 32% of construction costs, now that we are familiar with the Diamond House plan. The A4ARCHITECT.com Diamond House plan methodology of construction manages to achieve the 32% construction savings through utilizing a holistic approach, meaning all the elements that are necessary for a building to be complete, that is the foundation, walling, roofing, doors, windows, ceiling, external work, septic tanks, are all worked and upon, and some amount of savings realized from each wherever possible. And in this case, we've managed to effectively save 17.24% of construction costs of in the substructures, that is foundations. Then we've managed to save 11.92% of construction costs in the roof structure. Then we've effectively managed to save 2.73% in windows, and 0.84% in ceiling finishes. Septic tank, a further construction costs can be saved from septic tanks design, as explained in the article that I have written. You can search on it on Google with keywords A4ARCHITECT.com septic tank Kenya. You'll find it there. Also, further savings can be achieved through the superstructure walling, whereby use of interlocking stabilized soil blocks can come in very handy to make a further savings. Also, if a third of the internal walls finishes are left natural in sort of a pattern, also will save a considerable amount of that, but we haven't included it in this estimate of 32%. This estimate is strictly dealing with the substructures, 17.24, roof 11.92%, windows 2.7%, and ceiling finishes 0.84. All of it totals to 32%, 32.72% of construction costs. Now, the next step, we'll study each and every of these elements and see how this is achieved. Let us now look at how the A4ARCHITECT.com house plan technology has achieved the 17.24% savings on the substructure. And the substructure, here we are. Substructure is the level below the ground floor level. That's a foundation. You can see here we are talking about 45 square meters of floor area. This is the floor. This is phase 1. It's exactly 44.83, so we round it off to 45 square meter. This is all this region, all the way till this toilet and bordering this wall here. That is phase 1. And we can see excavate this volume at over a meter deep. It will cost 4,300 shillings. That is $45 US. This amount of materials, materials, and this is the amount of labor. This is a total amount. This is a total amount in Kenya shillings, and this is the total amount in terms of US dollars. So we are going to return, fill and ramp selected excavated material around foundations. That will cost 2,800 shillings. That's around $30 US. Load and cut away surplus excavated material from site, costing around 7,900 Kenya shillings. That is $83 US. And we are going to have approved hardcore fill, costing 10,800 shillings. That is around $113 US. And these prices are derived from the current material prices of Nairobi and its environments. And for example, a 25-ton lorry costs of hardcore costs 15,000 shillings in Nairobi. And here we are going to again use anti-termite treatment on the foundation, costing 3,600 shillings. That is $37 US. An anti-termite costs a liter costs 2,200 shillings in any hardware shop in Nairobi. So at least a liter will be used for 45 square meters. Then 1,000 gauge polythene or equal damp proof membrane. One roll costs 4,500 shillings in Nairobi. So for 45 square meters, we are going to have it will cost 2,700. That is $28 US. Then we come to mass concrete. Now this is where savings are achieved. You can see mass concrete in any other normal types of foundation. There is a mass concrete of class 15 to 21 to 3 to 6 concrete. Here none of it is used. Again, we have vibrated reinforced concrete 1 to 2 to 4. Again, Here this element is replaced with masonry walling. That is how we are achieving some savings here, by replacing reinforced concrete with masonry walling. And let's compare the cost of reinforced concrete. The cost of reinforced concrete is calculated as below. It comes to around 9,260 for a cubic meter, and it's derived as follows. A cubic meter of concrete weighs 2,322 kilos. Using this ratio of 1 to 2 to 4, that means cement will be 331 kilos, sand will be 663 kilos, ballast will be 1,326 kilos. And using the costs of materials, current cost of materials, sand per ton is around 1,600, cement per 50 kg bag is around 750 Kenya shillings, ballast per ton is around 1,000 Kenya shillings. This brings 1 cubic meter of concrete to using 4,975 shillings in terms of cement, 1,100 in terms of sand, and 1,300 in terms of ballast, all of it totaling 7,400. And add 25% labor, that is 9,260. And also not forgetting that reinforced concrete goes with steel, so there will be steel reinforcements added onto the reinforced concrete. Again, this steel reinforcement in this method of ours is not going to be used, thereby achieving even further savings. So we are gonna have 150 thick ground floor slab. Again, all of it has been replaced with masonry walling, and thereby costing us 36,000 Kenya shillings, that is 378 US dollars, and I've priced it at 804 shillings per meter squared. And this amount is derived from the cost of stone. A machine cut stone costs around 60 bob, delivered to site around Nairobi, and a square meter costs around 660 bob. That is 60 bob times 11, that's around 660 shillings. And add a percentage for labor, that is what is bringing us to 804 shillings. And again, you see, we are not going to use this A142 steel wire fabric mesh reinforcement on the foundation, so we've saved all these amounts. We've saved mild steel rod reinforcement, 8mm, 10mm, 12mm. All of this steel amount again has been saved. And so here we come to the walling. The walling is just as normal as any foundation walling, and the cost, there is no savings on the walling, and there is no savings on the cement, sand, plaster, on the plinth, concrete plinth. That's just like any other house. Some painting will be done like any other house. So the total savings compared to normal foundations, total savings is 104,000 shillings compared to a normal foundation. As in, if you were to use the normal foundation, we are going to add 178,000 plus another 100,000 shillings. So we've saved that translates to around 1,095 US dollar, and that's 36% savings on the total cost of foundation, and a 17.24% savings on the total construction costs. And we You can ask where has this been done before, and we can travel all the way till the town of Nakuru in the Rift Valley, Kenya. Here we are, and we can study. This is Nakuru town. This is the State House. Before you get to Nakuru town, here we are. This is the Hyrax Hill, and view to Lake Nakuru from Hyrax Hill. This is the Hyrax Hill Museum. It's very old, over 50 years old. They have utilized that method of foundation construction, and the building still stands very strong to date. Again, in the NYS Nyandarua, somewhere in these ridges between Nakuru and Nyahururu. This is Nyahururu, somewhere here. Here we have Nyandarua NYS College, again a building that is well past over 50 years old. That's the officers' mess, has utilized the same technology, and it's standing till to date. And yes, we've just seen how the A4ARCHITECT.com German house plan manages to save 17.24% of construction costs in terms of foundation. Now the next element in our building is a reinforced concrete frame, that is the ring beam, and in this case the ring beam uses reinforced concrete. It's still being used here, and we are still using the twisted mild steel reinforcement like any other building. So here at this area there's nothing much that is usually saved. The ring beam is just like any other normal house. Again, when it comes to superstructure walling, this is where I had explained earlier that if some parts of the walls are left bare, natural, looking like a pattern, then there can be some considerable amount of savings. Or if at all interlocking soil blocks are used, there will be around 17% further savings in terms of construction. And but in this case we haven't considered it. We are assuming that all the construction here will use a masonry wall, and all the walls will be plastered, all the walls will be painted. These totals to around 78,000, and that's around $823. Another major element that achieves these construction cost savings is in the roof structure, covering, rainwater, goods and finishes. And you can look at the roof in 3D format here, and this is the diamond house plan. You can notice that the roof is from here is not visible. The roof shape is not visible. The roof slopes at a slight angle, as opposed to this house here. This is the same diamond house plan layout, floor plan, but with an angled roof. And the savings is in that this surface area, if you can see, this surface area is far much larger than when the roof surface is slightly close to flat. This roof surface here is around 6 degrees in steepness. So there is a major savings in terms of roof material. Then again, the timber structure that the roof frame that supports. Here we're only talking about one length that spans across from one wall to the other, and as opposed to in this kind of pitched roof, whereby maybe let me explain it better in terms of section. You look at a section of this house, you cut it through, you see it's opening the section, and you can see this is the one behind is the pitched roof, and you can see all these elements. These are timber structure elements that are pitched roof, and what you're seeing here in front is a diamond house. This one is a diamond house, and here this is the angle of the diamond house roof, and you can see there is no the roof structure supporting element is only the rafters, as opposed to this one which has the struts, and that is what makes this kind of roof more expensive than the diamond house type of roof. Now we can look at the exact calculations of that. In the diamond house plan with the flat roof, you're talking about 35 linear meters of rafters, costing around 7,000 shillings, that is $77 US, and this can even be further reduced if at all poles are used instead of rafters. They have a further savings, because a 3-meter pole costs around 100 Kenya shillings, and that translates to 33 shillings per linear meter. This is a method that is heavily used in Uganda. Then we come down to the wall plate. This is a wall plate like any other house, the same linear meter, the same fascia board, and now here is the savings. Look at here, this roof costs 14,400 in terms of roofing tile or roofing sheet, and the surface area is 36 square meters. A pitched roof of the same house will cost close to double, around 80 square meters. And so this the surface area, and this roof rafters, struts and tie beams, all of them combined give a total savings of 58% compared to a pitched the normal pitched roof of the same area, and an 11.92% savings in terms of the total cost of construction. So that's 71,000 shillings savings. That's translated to $757 US savings when the A4ARCHITECT diamond house plan roof technology is used. And this A4ARCHITECT diamond house plan was inspired by a design that I did around 8 years ago in a country called Botswana. Botswana is you pass this from Kenya, you go to Tanzania, you go to Zambia. Here we are. You go to Zimbabwe, you end up in Botswana, and the capital city is Gaborone. And here we are. The house was designed somewhere in section 42, this area of Botswana, and that is what has inspired me to come up with to add it a bit, add a few technology here and there, and package it all up into the diamond house plan as we are seeing it. Another area where the A4ARCHITECT.com diamond house plan methodology has worked upon is on the windows, and an aluminium window of a meter squared costs around 5,000 shillings complete with glass. Steel casement window of the same area costs around 5,000 shillings complete, and a louver window the same area costs around 2,000 shillings complete. Now with this, we've calculated it, broken it down, and we are going to have the normal kind of precast concrete weathered window sill that costs us around 1,600 shillings, that is $16 mahogany weather and or window board of around 1,200 shillings, that is $13. The same pelmet box that we have in any normal house, and now the savings come in the use of a louver system. The louver system, the current Nairobi price, that is 2011 price for the louver system, and is 860 for a meter long window in hardware shops around industrial area, and the Kenya shilling 600 in hardware shops outside the Nairobi CBD area. And with that, if we add on to labor, we can use labor and transport, assuming it will come to around 1,700, brings it to 13,600 shillings, and that's $143. And assuming glass will cost us 960 per linear meter, that one will bring to per square meter, that brings us to 9,600 shillings, that's around $101. We have some more square glass for the toilet area, and when all this is added up together, you will notice that we have a 16,480 shillings savings, that's $173 savings. That is 33.5 to 3% in terms of the savings on windows, and 2.73% in terms of the total construction cost. We can look at the window design here, and here this is how the diamond house plan windows have been designed. You see, this is a 1 meter square window. It divided into two, so it's half a meter, and now we have one window is fixed and the other window is louvered. This way, very high aesthetics are achieved, and a considerable amount of savings to the total budget. We've just seen how to save 2.73% of the total cost of construction using the windows, and let's move on to other elements. We have the doors. Doors is the same, the normal kind of construction, and the A4ARCHITECT.com house design methodology uses the same doors, so there is nothing much. Only a word of advice, when it comes to doors, try and keep everything local. If you're in Kenya, try and use locally manufactured doors. If you're in Uganda, the same thing. If you're in Southern Sudan, the same thing. Wherever you are, whichever country you are in, the savings will be achieved when you use the locally manufactured dough, because it comes usually at a lower cost than an imported dough. Then here we come to external finishes. In external finishes, in the Diamond House plan, we've specified plaster all through and paint, totaling to 26,000 shillings, that is 276 US dollars. But a further savings can be achieved here if the exterior walls can be left natural. For example, you can see this is a natural machine cut finish, so there's nothing much in terms of an added cost in terms of finishes. Compared to this is where there's a plaster and paint on top, which is an added cost. Therefore, it's up to the taste of the house owner. If they want it left natural like this, they can have it like that. If they want it plastered and painted, it's all good. Then we go to the floor finishes. In this case, we've used the normal plastered cement, and we haven't added any ceramic tile or finish on top. So this is the same cost as any other construction. And again, when it comes to internal wall finishes, here is where we say that if at all some walls can be left bare, and some walls plastered and painted, assuming a third of the walls are left bare, so we're talking about a third of the finishes costs. So again, here there's some amount of savings that can be achieved, but we haven't in this 32% of A4ARCHITECT.com methodology, we haven't included that. But if that one is included, of course it will go, the savings will be far much higher than 32%. Another element where there is a considerable amount of savings is in the ceilings area. In this stage, there's a considerable amount of savings in that the same timber structure that is used to support the roof tile is what is used for the ceiling. So that the same timber structure that supports the roof tile will be the same timber structure that is used for the ceiling. Therefore, there will be no needed additional brandering. This brings a total percentage of 10.9 in terms of overall ceiling costs, and a total percentage of 0.84 in terms of overall construction costs. We've just seen how the A4ARCHITECT.com Diamond House plan manages to save 10.9% of ceiling costs and 0.84% of the total overall construction by ceiling design intervention. Now we go to other elements such as sanitary fittings. Basically, these ones are bought off the shops, so when they are complete, and here there is no difference between the A4ARCHITECT.com Diamond House plan and any other construction method, since these are fixtures that are bought complete from any hardware shop. And we go to the documentation consultancy fees. Documentation consultancy fees is an integral part of a construction cost, and that is the fees that is used to pay the architect for the service rendered, and the output of this is an architectural floor plan, architectural drawing, and site supervision. And in this case, the architectural floor plan complete with all the details will cost 30,000 shillings, that is $319, and this output is available online, and as in somebody can request through an email, and this given out in terms of a PDF attachment to email of a drawing of A4ARCHITECT.com house plan drawing that can be printed out and used in construction. And we can break down how this consultancy fees is achieved by going to the A4ARCHITECT.com website, and here we are, and you go to architectural consulting service link, and this link explains how the architectural consultancy service is broken down. From part A, there is inception, that's advising the client upon the services of various consultants, it's a zero charge. And part B, outline proposal, it's at 1% of the total construction cost. Part C is a scheme design, is at 1.5% of total construction cost. We go to part D, is a detailed design, is 2% construction cost. Then part E, tender actual to completion, that is supervision, is 1.5% of total construction cost. And this has been derived this way, and we have inception is 0% for phase 1, outline proposal is 1%, and that is 1% of 675,000 shillings, that is 6,700 shillings, that is $71. Scheme design is 1.5%, that is 10,000 shillings, that is $106. Detailed design is 13,500 shillings, that is $142. Then supervision costs 10,000 shillings, that is $106. All of it totals to 40,000 shillings, so 40,500 shillings, and that is $400. But outline proposal, scheme design, and detailed design is has an output in terms of a drawing, so that this part can be available for here for $319, that is 375,375 shillings, and it can be availed upon request to info@A4ARCHITECT.com, and will cost this much. Then we come to the prime cost and provisional sums. These are external works, mostly electricity connection. We're talking about septic tanks, cold water installation, and These ones, the costs are usually more or less constant. There's no big difference apart from the septic tank, whereby I've outlined a method of how you can reduce costs in terms of septic tank design, and this method I put it online. All you need to do is just go to A4ARCHITECT.com, go to Google and search for A4ARCHITECT, search, and here we are. Once you're here, and once the website opens, you come here to the search and search for septic tank. Within the A4ARCHITECT.com website, and you scroll, here it is, and this is article that I've written explaining how construction costs of septic tank can be saved. And you can see this is a picture of a septic tank in an old house that is located in the outskirts of Nairobi, in the Adams Arcade area. It's a big house around 300 square meters, and this is a septic tank that this house has been using for the last over 50 years. The septic tank, as you can see, is 3 meters long and 1 meter wide, so it's 3 meters squared, with an average construction cost of 15,000 shillings per square meter. That comes to 45,000 shillings to construct this size of septic tank. And here I've explained in detail what a septic tank does. It's not a storage device, it's a curing device, and so its use is to cure, not to hold. The holding device is a soak pit that can be any size as you wish, but the septic tank can be, if the design is kept as to the A4ARCHITECT.com specification, it works as well, and it will save a lot of money. So we've seen how the A4ARCHITECT.com diamond house plan method of construction achieves the 32.72% savings in terms of technology. That is whereby we have 17.24% in foundation, 11.92% in roof, 2.73% in windows, and 0.84% in terms of ceilings. And we've seen that more than 32% can be achieved if someone was to utilize the A4ARCHITECT.com method of septic tank construction, which is available on the internet. Search on Google with keywords septic tank A4ARCHITECT, and also a further savings can be achieved through use of designs on walling that I've described, where let's say a third of the wall surfaces are left natural, unplastered and unpainted, and all this will result with to 32.72% or higher in terms of construction savings. And now let's look at number 2, the second step that we said is phased construction. In the diamond house plan, for example, phase 1 is 45 square meters, and phase 2 is 67 square meters. Phase 3 is 92 square meters. And phase 1, this is a breakdown of the design the design cost. Phase 1 design costs will total to 40,500 shillings. Phase 2 design cost comes to 60,000 shillings, that is 634 US dollar. Then phase 3 we are talking about 82,000 shillings, that is 871 US dollar. In terms of full consultancy fee from inception all the way to periodic supervision till completion. And phase 1 is estimated at 675,000 shillings. Phase 2 is estimated at 1,005,000 shillings, and phase 3 is estimated at 1,380,000 shillings in terms of construction costs. We can look at the phases once again. This is phase 1, comprises of the living room area and 1 bedroom. Then phase 2, living room area and 2 bedrooms, and phase 3, living room area and all the 3 bedrooms. And when the house is constructed in phases, there will be maximum utilization of resources in terms of the finances required to construct, in that assuming maybe it's a young family with space needs for only 1 bedroom, therefore they will not require to construct phase 2 and phase 3, so they'll only use your resources, that is 676,000 shillings to construct the first phase only, and utilize it. And once the family unit becomes bigger, so they will require more space, and therefore they require to construct to expand. That's the point where they'll move to phase 2. And again, if the family unit increases or the space requirement become more, they can go to phase 3 of the diamond house plan. And the house is designed such a way that it's very easy to move from phase 1 to phase 2, and to increase from phase 2 to phase 3. It's designed to seamlessly increase in phases. Therefore, this way you find if what the family can afford or only require is space requirements that can be dealt with using phase 1, then they will have saved the money required for that could have been used to construct phase 2, use it for another useful purpose. And once the space needs increase, they move to phase 2, and if they increase more, they move to phase 3. That is how phased construction effectively manages to enable maximum utilization of resources. And the third step, as we had outlined, is use of labor-based procurement method. And labor-based procurement method in this case is made easy because once the house owner knows, for example, let's say this is the foundation, and they know how many stones that they require in terms of foundation. They know they require maybe X amount of stones for foundation. With that information, they can be able to have a contract with a contractor for labor. So they will know they will supply to the contractor X amount of stones, and the contractor will charge Y amount of shillings for labor. Once that element is tackled, they move maybe to walling. They know how many stones they will need. They go to windows. They know how many number of windows they will need. And once the house owner is armed with all this kind of information, they have the number of materials required, and they also have the drawings. They can be able to procure using the labor-based procurement process, as opposed to where it's labor and materials. Labor and material contract is where the contractor supplies both labor and materials, so the contractor makes a profit on the materials, and the contractor makes a profit on labor. In this case, the contractor only makes a profit on the labor, and the house owner supplies the material. And for the house owner to supply the material and to be able to control the costs, they need the information to know exactly what is the estimated cost of the materials and the quantity of those materials. And that is what the A4ARCHITECT.com diamond house plan gives as a solution for that kind of procurement process. And we've seen how the A4ARCHITECT.com diamond house plan manages to save 32% of construction costs through technology, through use of phase design, and through use of labor-based construction procurement methods. And now we can look into go back in a bit of history and see a few pictures of the A4ARCH Hill museum located in Nakuru. And we can go to Google and search for A4ARCH Hill, Hill, then A4ARCHITECT, and this will take us to this article I had written a while ago, and on how to save construction costs. Then once it opens, you can be able to find a picture. Yes, here we are. You can scroll down, and here we are, and there is a picture. This is A4ARCH Hill Museum. You can see this wall is this is a masonry walling, a masonry stone that has been laid horizontally to form the ground floor, and this is what the diamond house plan specifies as a method of construction cost savings. And this A4ARCH Hill Museum has been standing for over 50 years. It's a very strong building, and this is what they have utilized. And these diamond house plan methodologies have been designed for optimum use on ground floor houses. Ground floor houses, as in bungalows, as in there is no other level on top. This is just a ground floor, and since the ground floor foundation footing is not as heavy as this is how a footing looks like. Here we are. This is under the ground, and there is usually this kind of walling. This is a wall. This is a foundation walling. Then this is a footing. This element is what is used with concrete, reinforced concrete, and now we are replacing it with masonry walling. We can also look at technology. The A4ARCHITECT.com diamond house plan technology is also available on other kind of house design, as we can look at this house design which has utilized the A4ARCHITECT diamond house plan technology on the roof. You can see the roof is similar, and of course the foundation is similar, and the windows are of the same nature. And these methods very helpful in reducing construction costs. And as of now, they are best utilized when it's a ground plus one, ground only, without ground and plus 1, 2, 3, 4 other levels on top. And there are other methods that have been utilized in the 16th, 17th century by the Omani Arabs in the construction of the Fort Jesus. We can go to Google and search for Fort Jesus A4ARCHITECT, and it will take us to this article he had written a while ago, explaining the method of construction of Fort Jesus. And from here, yes, we can see the Fort Jesus was built in 1593 by the Portuguese, and later on in 1698 by the Omani Arabs. This is where we are zeroing in. The Omani Arabs came in with this ground plus one technology. This, what you're seeing, are timber structures, then which are supporting these coral stones on top here, which constitute the suspended slab. And this suspended slab has not used any concrete, it has only used a timber structure and a stone laid on top of it to enable it to do the ground plus one suspended kind of volume. We have just seen how the A4ARCHITECT.com diamond house plan technology effectively reduces construction costs by 32%. And thanks for watching, and have a good day. Thank you.